Hi, everybody. Kyle McMinn here for Wellness Roundtable. Welcome to another installation. Today we'll be talking about homeostasis, or the body's internal monitoring system and main. So you should see my screen now. Um, so here we're going to go right in. We have 15 minutes, so I'm just going to cover initially um, all of these topics. Okay, so just specifically as it relates to the internal human environment, which I believe is the key to understanding individualized training responses to programming. Some of these slides you may recognize from the previous installation on Saturday. However, so we're going to start with the same question. How do I optimize my response to training while minimizing injury risk? Um, you know, the concept is we need to learn our own individual training capacities from the inside out. So you, as the human being that you are, really should know your body better than anybody else, including those that are prescribing your training. Um, if you don't, then no one does. So that's the scary thought there with the emoji, is that if nobody knows your body, you don't. Well, then it could be rest assured that you don't. Nobody else knows much about it either. Um, Three prevailing things I'd like to continue to think about are humans that are all unique. We're all human biological systems, and we're all unique. So, as pertaining to that, we all have unique and individual responses to different types of stress. Um, the same thing I kind of said on Saturday is that the training does not occur in a vacuum. And this goes along with the next point about the holistic approach. And we train the human being, we don't train solely the muscle. Okay, so human beings, we all have jobs, or we're athletes, or we're researchers, or we're students. Um, so not often do we come into the weight room and have no other stress factors affecting our preparedness to train or to produce force than solely what would be required of the muscle. So our ability to exercise, our ability to demonstrate force, and to create what we like to think is our weight room performance is going to be a factor of many different things. So just fundamentally, we have 15 minutes here. I only have 4 slides or 5 slides, so we can get through this pretty quickly and leave some time for discussion here on each slide. So again, the concept of homeostasis, or that internal environment, or the stability of that internal environment that we discussed, is the maintenance of a consistent familiar state in response to stressors. Okay, and just kind of to review a little bit, then we'll move past this slide. We have regulated and non-regulated variables. Again, we have receptors with regulated variables that track specific variables and modulate those variables through regulatory feedback. An example of this would be blood pressure, as the baroreceptor makes adjustments to stabilize blood pressure. And then we have a non-regulated variable, which is a variable that has no specific sensor to track it, but may be modulated as a means to stabilize a certain factor. In this case, we'll use heart rate. Heart rate is something, again, that your body doesn't specifically track. We do with a polar monitor or a heart rate monitor, but your heart, or your body doesn't track it. It's merely a product of the autonomic nervous system, and as a means to regulate normal, stable blood pressure through baroreceptors. Okay, so just remember also too that this largely happens without our conscious awareness. So that's an important factor. Um, so I think it's important that we all understand that we're all individuals. So we all have what we consider, or what we call, a genetically influenced set point. This theory is prevailing, although it does, there are some theoretical issues with it. But in large part, this seems to be the case, that we all genetically come with a certain set point. Okay, here in the model on the left-hand side there, we have a compensated factor, which is what we consider a physiological factor. and it's controlled through negative feedback loops with intake. So essentially, that compensated factor uh, is affected by and affects intake. So an example of this would be leptin. An increase in leptin release from fat or by adipose tissues decreases the hunger response, and this is specifically over time. Okay, so this is not necessarily meal to meal, but it's more of an over time kind of thing. So we see an increase in leptin over a day, 2 days, 3 days a week. We know that our body has maintained um, normal caloric balance, and we don't need to increase or eat any more than what we typically would. Okay, so we are not starving at this point. We are properly satiated. With a decrease in leptin, we see an increase in satiation or an increase in hunger, that hunger response over time. So genetics tells us that there's a dictated set point level that is defended. So defended or stabilized or protected. So your body does what it can to maintain a certain level of that leptin in this case, as I used. Significant deviations from the set point um, occur, and they do that until these levels recover. So any significant deviation from that set point of leptin in that case will continue until the level of hunger, pardon me, or that level of calorie intake or our caloric reserve goes back to normal and what would be typical of what we would need and necessitate our daily activities and workouts or whatever have you. So, just as an example, obesity is a product of a compensated factor dysfunction. In this case, it would be leptin and genetics. So, that compensated factor, leptin, we see resistance to leptin, and then we also then see a creation of a new set point. Um, so, we see that compensated factor leptin having issues, and we all know that the genetics plays a big role here. So, BMIs are more similar among family members than those that are unrelated. So clearly there is a genetic factor here, and then there's also our or physiological factors or compensated factors here with leptin. So moving on to this slide here, understand this is the concept of the central governor or the maintenance of homeostasis. And this we're going to now start applying to exercise. So the brain regulates exercise performance by modifying the number of motor units recruited, or the amount of muscle fibers, the amount of muscle being recruited. This is a result of both conscious and unconscious factors. Okay, so some of these factors are listed on the top left-hand portion of that figure by Noakes, 2012. And that ranges anywhere from an issue of emotional state to sleep deprivation to visual feedback issues, lighting in a room, carbohydrate mouth rinsing. Are you able to stave off fatigue that way? Body cooling. So you can go through some of those things up there. Any presence of inflammation, rate of. So a lot of those things on that slide or on that figure are factors that affect how the brain is going to regulate how much muscle is going to be recruited. What we see generally in exercise is the generation of what we term an unpleasant and illusory sensation of fatigue. So as we're lifting weights, man, things get pretty heavy or we're putting a lot of effort in, fatigue begins to mount. Once fatigue begins to mount, we generally associate that with a negative feeling or a fatigued feeling. So the purpose for this, and we'll go down to Maso here in 1915, humans always exercise with a reserve. So although we always say we want to give 110%, we want to give 100%, well, in all actuality, human beings always exercise with a reserve of energy. And we do that to avoid a massive failure of homeostasis, which we want to avoid at all costs. So from that sense, although you may be laying on the floor, you may fall, you may get tired, you always have a reserve of energy. The human body is developed that way. And Maso in 1915 determined and actually termed this fatigue as the human body's most marvelous perfection, particularly against injury that would occur if there would be no reserve. Then who knows what would happen. And another Noakes point here is that record performances are achieved by those that control the progression of those illusory sensations the best. So he relates the fact that in two equally talented, skilled, and athletic track runners, the winner, if the two were to race, the winner would be the athlete for whom defeat is the least acceptable rationalization, or the one that can control those illusory sensations the best, I guess, for lack of a better term. So, yeah, I mean, fatigue is not only physical, but it's also psychological. And we all have different perceptions of how that fatigue feels. And it is very fiber type oriented. So, a type 2 fiber athlete may feel different than a type 1 fiber athlete. So, in just our little 15-minute discussion here, we've gone over the concept that the human body, each of us have an individual set point and compensated factors levels that are specific to us, but also that are handed down through our genetics. We understand that going back through here, we understand that after this that we have that set point and that it can be deviated, and then we deviate as that deviation, or we compensate until that deviation has ended. We know that the central governor theory is not just about physical effort, it's about psychological effort and your perception of effort, or your perception of the environment, and the fact that human beings always exercise with a reserve, and that it's very individualistic, our perception of how hard that exercise is. And that our brain regulates how we perform on a daily basis, no matter what we're doing, weightlifting, going to the office, whatever may have you. So next time, what we're going to discuss is the body's response to training and the application of stress. So now we know that we each individually are going to respond to training much differently. We each have our own propensity to train under stress. Now we'll discuss next time how our body responds to that. And then also how you can track or monitor your individual responses to that training. So you may be asking yourself right now, okay, well, great. So what does that mean for me? How do I track how I respond to training and to stress? Well, we'll discuss some of those things. Also, a topic for next time is going to be, what can I do right now to begin to learn my body? And this whole series of lectures is going to be geared upon your ability to learn not only your body, but how to learn a body of a client who maybe you're training, how to learn what the responses are. Why are they getting so sore after certain exercises? Why on a Tuesday are they coming in, or you coming into the facility saying, like, I'm drained, it's only Tuesday, I'm not sure what's happening. But on Friday, there's a more increased willingness and potential to train hard, given it's the end of the week. Maybe that's a little confusing. So next time, what we're going to do is discuss how we can figure these things out, what specifically you can track and monitor to keep kind of a catalog of how am I responding to this training. And then that way we can also then decide and start discussing how do we avoid fatigue, excessive fatigue, overtraining, and then injuries. Okay, so I thank you for coming in today. Remember, you can always email me at my first and last name. It's Kyle Scott or Kyle S. McMinn at gmail.com. Unfortunately, I could not see any of your comments today, so the web-based program here does not allow me to see the comments. So if there's any comments you want to, feel free to email me. Go ahead and email me at that email address, Kyle S. McMinn at gmail.com. Okay. Again, moving forward next week, be prepared to talk about or to understand how to track these specific responses to training, and we'll see kind of how it goes then.